Okay, so we seem to be live. Can one of you please confirm that on YouTube?
Yes.
Excellent. All right. Hello, everyone. First of all, thank you for joining us on a Saturday morning. I know it's nice and early and some of you have holidays, but very kind of you to come along. The reason why you have come here today is because it is the birthday of Professor C.V. Raman, who is one of the Nobel Prize winners from India. And what we are planning to do is start a new series as a part of a new initiative by INYAS. And this is basically aimed at popularizing science from India, from the past and from the present. So hopefully this new initiative is going to help you understand what is the latest science that is going on here, and also the heritage of the wonderful scientific achievements that we have from scientists in India. So just to introduce this new initiative, we have our chair, Chandra, who will be saying a couple of words to tell you about why we are doing this. Chandra, the mic is yours.
Yeah, thanks, Anup. And good morning, everyone who have joined today for this new INYAS series, which is named as Scientists from India's Past and Present. In short, we are calling it as SIPP. So as Anup mentioned, the aim to start this series is to recognize and to appreciate the work, top quality science work from Indian scientists, and to encourage our young researchers, young students to develop their career in science based on the inspiration from the past. And also, as a part of this series, we will also highlight the contribution of our current colleagues who are working in various aspects of science, in different streams of science, and are publishing their work in top quality international journals. So INYAS platform will appreciate, will recognize their work through the social media. So this series will be having two parts. Monthly, we will be having online lectures, preferably by INYAS members, on the contribution of Indian past scientists. Like today, we are going to celebrate Sir C.V. Raman's birthday, and it's a pleasure to have our speaker, INYAS member, Dr. Ramanathan, who will be talking about Professor C.V. Raman's his life and his effect in detail. So the whole idea of this series is to talk about the Indian scientist from past and the present, and we hope that this will help us in popularizing the Indian science at the social media platform, through which we can make an outreach to the people who are not really aware about such contributions from our own scientists. With this, I request Anup to introduce the speaker and start the today's talk.
Thank you, Chandra. As you said, we are looking forward to this, and hopefully we'll be able to popularize Indian science a lot more than we have in the past. So for today's talk, we have Professor C.V. Raman's his life and his effect on science in general. That is going to be our topic itself. But to start off, let me just introduce the speaker. Our speaker is Dr. V. Ramanathan, who is based at IIT BHU, and he's based at the Department of Chemistry. He's a physical chemist trained in laser spectroscopy, Raman microscopy, and computational chemistry. His PhD is from IIT Kanpur, and postdocs were from South Korea, from Switzerland, and Germany. His current research is focused on surface-enhanced Raman scattering and applying Raman imaging in biology and medicine. He has interest in history of science in ancient medieval India and theoretical aspects of Carnatic classical music. He is a Fulbright scholar and was a National Core Committee member of INYAS itself. I think we have lost the connection for him, unfortunately. So just give me a couple of seconds, and I'm sure he'll be here to start speaking. Oh, welcome back, Ram. Okay, so Ram, with that, I'm going to hand over the mic to you, and please go ahead with your talk. Thank you.
Thank you very much, Anup. At the outset, it's indeed my prized opportunity today to speak about my scientific hero, Sir C.V. Raman, and on his birthday and from the platform of INYAS. With that, I extend my hearty thanks to the chair, Dr. Chandrasekhar Sharma, as well as the committee which bestowed this opportunity on me, with which this wonderful series of scientists from India's past and present online lecture is being inaugurated. So, and just off the record, this is indeed a golden opportunity for me, as perhaps this may be the last opportunity as an INYAS member, because for those who do not know, INYAS is a group of young scientists whose tenure is 5 years, and I'll be completing my 5 years by this December. So going into the talk, as I said, it's indeed a great opportunity to talk about my scientific hero on his birthday. So before I begin narrating the details about his life, about his effect, I would like to disclose the source or the resource from which I have culled or collated my content for this talk. These are among the biographers of C.V. Raman. Professor G. Venkat Raman has been the authoritative one. And fortunately for me, he was my professor during my undergraduate days, undergraduate and postgraduate days. So these are two very beautiful monographs. On the right that you see is a blue one, Raman and his effect. It's a very summarized version, very small, very thin, meaning you can finish it within a few hours, 1 or 2 hours. Whereas on the right, the yellow one with his image, this is a very detailed compendium about his life. It's very thick. And needless to say, this has been my source of inspiration and from which I have taken the content of my talk. So just to give you a brief outline, I will be talking about C.V. Raman's pre-Calcutta days, or those pre-Kolkata days, which is from 1888 to 1907, then followed by his days in Calcutta as in the finance department, and how he evolved from being an inspector in the finance department to a professor, and then how he undertook his maiden overseas voyage. Then finally the climax, the effect, and then certain applications or avatars of Raman effect, which I can very safely and confidently say is that Raman himself would not have anticipated. There are reasons for it, and I will be touching upon them as I'm going about. So those of you, our country is a huge country, and despite being in the digital era, there are still a lot of ignorances about different places of our own country. Because many times when I randomly conduct survey with the first year JE students who are predominantly from North, they don't even know what are the 5 different states in the southern part of India. Anyway, that's aside. So this is the map which shows the birthplace, born exactly on this day, 1888, to R. Chandrasekhar Iyer and Parvati Ammal in a place called Tiruchirappalli, which is called Trichy in short. And you might associate the National Institute of Technology, NIT Trichy, which is located in this city. So here is a younger photo of C.V. Raman in his younger days, which is encircled in the red. He was second in a battalion of 8 children, 5 sons and 3 daughters. One should not be judgmental about it because it's that time and era that we are talking about. So from any point of view, this is a modest number. His father was a teacher in a school who later moved to Vishakhapatnam to be a lecturer in mathematics and physics in Mrs. Avian College, where when Raman was just 3 years old. You might see that I have put in also the equivalent of US dollar during that time, and also about the cost of 1 gram of gold, for you to just give an impression of what were the economic conditions of the time that I'm talking about. Because today, if somebody says somebody is working for 85 rupees a month, it's no less than a joke. C.V. Raman matriculated at the age of 11, and during that time there was something called FA. That was at the age of 13. So FA is something what we right now have the 11th and the 12th, although the age has been shifted, and he got his BA, that is a bachelor's degree, at the age of 15 from the Presidency College in Madras, which is now called as Chennai. And needless to say, he was a gold medalist in both English as well as physics. So this is a quote from his own, which I read. Indeed, in the first English class that I attended, Professor Eliot, addressing me, asked if I really belonged to the junior BA class, and I had to answer him in the affirmative. He then proceeded to inquire how old I was. This is because very early on, it was like Raman was jumping ahead his classes, something like getting double promoted or getting triple promoted, and his stature was also not very tall. So he was the youngest among the class that he was attending. And then he had finished his MA at the age of 18, again with a gold medal, and whatever possible accolades that the university had to offer. And very noteworthy here is that he was exempted from attending all classes of science. This is very unique and very unique aspect of the education system prevailing at Presidency College during that time, because Raman has to say that Professor Jones of physics believed in letting those who were capable of looking after themselves to do so, with the result that I enjoyed a measure of academic freedom that seems almost incredible. During the whole of my 2 years work for the MA degree, I remember attending only one lecture. And whenever I say this to my students, I say, let's better not emulate this aspect of bunking the class, rather emulate his intelligence. So that was Raman. He has his first research paper even before he completes his master's at the age of 16, and that too in a very reputed journal of that time, the Philosophical Magazine, on diffraction of light from prism. And another on measurement of surface tension, and it was communicated by the author, single author paper with no acknowledgements. And by the way, this was the first ever research paper from the college, so you could understand how much ahead of time C.V. Raman was, and with how isolated, in an isolated atmosphere he was kind of working. So that shows what is the makeup of his brain. Today we talk of ecosystem, we talk of like-minded colleagues in a department to discuss and generate ideas. But just compare that. I'm not judging here which is right or which is wrong, but I'm just trying to present you a contrasting picture here. So you could imagine that at the age of 16, Raman communicating a paper which is in fact the first paper from the college. And this is the unsymmetrical diffraction bands due to rectangular aperture. And like today, anybody's dream is to crack the UPSC or the State Service Commission, because it's indeed a stigma or a curse that all Indians have, is that after we finish our education, we need to get a government job. Again, it's I'm not judging it, but then numbers don't clearly add up, and it is in the recent past that we see a booming of entrepreneurial aspects, startups, and of course corporatization was always there. But back then also it was the same thing, that one has to crack some government exam and get inside a government service. So needless to say, he topped his civil service exam in the finance department. And this is the forerunner. The finance department is the forerunner of the Indian Revenue Service that we have today, IRS. And this is where the Raman sarcastically says that I shall ever be grateful to the civil surgeon of Madras. The reason is Raman was not found suitable for they had to pass the health checkup, wherein he was kind of lagging back, because of which he had some struggle. At the age of 18 and a half, he marries Lokasundari and then joined as Assistant Accountant General in the Finance Department Kolkata, with a salary of 400 per month. Much later, after the demise of Raman, Lokasundari seems to have very comically quipped that she discovered much later in their marital life that Raman married her only for an increment in the monthly salary, because bachelors had a different salary and a tax structure, and married people had a different salary and a tax structure. So we do not know the veracity of her statement, but this is documented in her biography that Lokasundari seems to have quipped that Raman was in her because of the increment in the salary. That's jokes apart. Lokasundari was a good veena player, and Raman was always interested in the musical instruments of our country, because you will see that in the next slides, he was obsessed for studying the harmonics that were produced by different musical instruments from our country. So there's again the biographer noted that on the very first day when Raman had entered the house of Lokasundari, he heard her playing the veena, and that captivated him so much that he straightaway proposed her and asked in hand for her marriage to her father. So then he travels to Bengal, which is the capital of the British India. So normally traveling towards the west is what is considered progressive, but here he travels to the east or northeast in this case. He travels to the capital of British India and not to the capital of the British Empire, because back then it was always an obsession to go to the capital of empire, namely Britain. That's where you can see that some of all the barristers that we know of, Raja Ram Mohan Roy, much little later, if we hear of say P.C. Ray, or if we come a little bit ahead in time, later in time, about B.R. Ambedkar, name any intellectual of our country before, say, independence, travel to the British Empire, capital of the British Empire, is like it's like a travel to Mecca. But then he did not take up that, and that also shows he was not following the herd. He was not having that kind of a crowd mentality. And much to his chagrin, having published paper in science at the college, he takes up government service and not science. I mean, in that aspect, the biographers are a little silent, because what prompted him to travel this far from Trichy to Bengal, leaving science? Was it the family economic condition? Those are something which the biographers are a little silent about. So in his Calcutta days, he was working in the finance department, but to his luck, he had this cultivation of science, which is there even now, Baobazar Street, Raja Malik Road, which was opened by Mahendra Lal Sarkar, with the sole intention that he had anticipated that younger men must come and step into my place, make this into a great institution. So when I always read about Mahendra Lal Sarkar, it's there in our psyche or in our thought process that at different points in time, we have always been thinking there has been a manthan or a churning of our thoughts to promote scientific rigor, scientific temper through in the young men, through experimentation and through indulging them in science. And what no wonder to say we have also INYAS, which again I see as a kind of a replica from what was there, say, 100 years back. And Amrit Lal Sarkar was the son of Mahendra Lal Sarkar. Amrit Lal Sarkar offered Raman a place and instruments to work at the cultivation of science. And let me tell you, this cultivation of science was started, if I'm not wrong, in the late 1880s or early 1890s. And then great works of P.C. Ray that we know of, the History of Hindu Chemistry, Volume 1 and 2, and the great philosopher of science, Brijendranath Sheel, all of them had their association with the cultivation of science. And even to this day, the institute produces some of the bright minds of the country. And I make it a point to highlight and reiterate this time and again whenever I get an opportunity about Ashutosh Day, sorry. Because we hear about European chemist Faraday, particularly the British chemist Michael Faraday, and whenever I hear a talk on the history of science, I even hear some of the prominent our own Indian scientists waxing eloquent about Michael Faraday's journey, ascent in science, because Faraday in his earlier part of his life was working as an assistant in a shop of binding. He was an assistant to a book binder, and because of his open-minded and curiosity, and he was a bibliophile, he just rummaged through all the books that had come for binding, and that's how he had equipped himself about with the scientific knowledge of his era. And that's then the history is witness of how he went on to create multiple achievements in science, which to this day we have it in our curriculum, and which to this day have stood the test of time and are applied. Closer home, Ashutosh Day is like the Michael Faraday of India. I am saying Michael Faraday of India because Faraday was little bit had lived earlier than Ashutosh Day, or else I would have called Faraday was the Ashutosh Day of Britain. But anyway, that's a different story. Ashutosh Day was an illiterate when he had joined as an assistant to Raman in cultivation of science, and he remained as Raman's assistant for 25 years. And as I said, Ashutosh Day was an illiterate and he never went to any university. And this paper that you see, a new method for the absolute determination of frequency, you might be surprised to know that this was a single author paper written by Ashutosh Day, which was published in Proceedings of Royal Society. So you can see the kind of Midas touch, if I may say so, that Raman had on people who had come in his contact. So this is the Midas touch that Raman had, which could convert an illiterate. It's not that as though I'm talking about his illiteracy, but I'm talking about the giant leap that Ashutosh Day had from being an illiterate to communicating a single author paper in a reputed journal. Now compare that with the education system of not just our country, for that matter, in any country. This is something that seriously policymakers have to think of in terms of institutionalizing the educational approach. That's a different story. I'll not get into. So this is a great inspiration for, at least for me, about the story of Ashutosh Day. Raman's routine in Calcutta is also very poignant. 5:30 a.m. he wakes up and goes to the association until 9:45. He works there, comes back to his home, does his usual course, and leaves in haste to the office. 6 p.m. he returns from his office and goes directly to the association, and he returns home only by 10 p.m. And on Sundays and other holidays, it was the entire day in the association. So this was his routine throughout, day in and day out, for every single day that Raman had stayed in Calcutta. So you can imagine the industrious nature of C.V. Raman and the hard work that has gone into it. This is again a lesson for all of us that it's not enough if somebody is intellectually well endowed. It has to always be complemented and supplemented by hard work, and hard work has got absolutely no substitute. And Raman is a standing testimony to this fact that despite being intellectually a giant, he was not shy of giving his 100% in putting the hard work. So as I said, he was obsessed with studying the harmonics of different instruments that our country harbors. What you see here are the instruments on which Raman had actually worked. Tanpura, tabla, mridangam, and veena. So he had also made an automatic violin player as well. This is the automatic violin player by which he had studied the different harmonics, and he had come to several very scintillating conclusions as well. And he had a lot of interesting things to compare. I mean, just to take digest a little bit, if you compare the Indian drums and the family of Indian drums, you get all this tabla, mridangam, maddala, all this, which have got double, they are all made of double membrane. As you can see here, tabla has got a white and a concentric black circle. So is the case with the mridangam as well. And Raman categorically showed that the harmonics produced by a double membrane like these are very distinct and pleasing compared to the harmonics produced by a single membrane drum, which is normally what we see in the Western drums. So I have not put the paper reference here, but those of you interested can just, this is available in Google very easily. His question was whether Indian instruments like veena and sitar produce good sounds. Is it a sentiment or has a physical quality ascribed to it? Today in psychoacoustics, this is a very poignant question, whether a pleasing sound, a pleasant sound is a psychological perception, or is it something intrinsic to the quality of the sound itself? And that was something similar, that question with which C.V. Raman was obsessed. And by looking at that, he had proved that there is a violation of young Helmholtz law, and this is about to do with the harmonics of the instruments. And he showed that how the Indian instruments produce more harmonics than other instruments. I'll not get into the detail, but those of you who are little familiar with Indian musical instruments, say be it sitar, or particularly if you take tanpura, tanpura has at one end has got the pegs and the other end has got one end is attached to the resonator and the other end is attached to the pegs. So if I may call, so this is the resonator, one end of the string is attached here, and this is the pegs that I'm referring to. So in the tanpura's case, and it's true for all these, even veena. So this is the resonator, it is attached to the end, and you have the pegs here. Particularly in the case of tanpura and little subtle in the case of veena, the timbre, which is the quality of the sound, gets majorly affected. In tanpura, we use something called as a jivari or a javari, depending upon where you are. In Bengal, they call it as a different name. In North India, they call it as jiva or jivari. In South India, they call it as a jiva. So unless you insert some thread in this end of the tanpura does not produce a harmonic sound. And this was very scientifically studied by Raman, and that's how he concluded that they produce more harmonics, and he also showed the violation of young Helmholtz law. I'll not get into this, but then this is a paper reference that those of you interested can have a look at it. And this was his address in the Catgut Acoustical Society of America, where he says that my studies on bowed string instruments represent a phase of my earliest activities as a man of science. They were mostly carried out between the years 1914 and 1980. My call to the professorship at the Calcutta University in July 1917 and the intensification of my interests in optics inevitably called a halt to my further studies of the violin family of instruments. So this marks a transition in, until now, it was C.V. Raman working as a inspector in the finance department, and his morning times and the night times devoted in the Association of Calcutta, studying the acoustics of Indian instruments. And when he transitioned from this place to Calcutta University, offered by Sir Asutosh Mukherjee, he was offered a Pallet professorship. This Pallet professorship is still there. Raman really jumped and grabbed this opportunity. And this, for many people, this was like a professional suicide or a career suicide, because from a salary of 1,100 rupees per month, Raman went into something like 600 rupees per month in the finance department to this professorship. I really wonder how many of us would be in a position to do this transition. But Raman, as he was the indomitable spirit that Raman had, he could easily do that. I hope I'm audible.
Yes, you are.
Yeah, okay. So the 1918, early 1918, late 1917, he transitions, and that's where his research focus also completely shifts, and he gets into optics. And in 1921, he makes his maiden voyage overseas, and he travels to England to attend the University Congress at Oxford, representing Calcutta University. And conference, as some of my professors used to say, it's like a mela, a congregation. But for Raman, it was not like really a mela. He made utmost use of all the times that he had. So this is the Whispering Gallery, and perhaps as a part of the conference entourage, they might have been taken to this place, and he just doesn't stop admiring this place. He ends up writing a paper on looking at it. So, and this gets published in Nature. So it's a Whispering Gallery phenomena at St. Paul's Cathedral. So this is just to impress upon you the fact that what kind of a keen, observant eye and an open mind that Raman had. Curiosity was his driving force, and his curious mind was never at rest. So that's, as they say, chance favors a prepared mind. In this case, it's not actually chance. It is like opportunities favors a prepared mind, if I may say so. So he had this open, curious mind. And one example of this is, even as a part of a conference entourage, he gets to do a scientific analysis and publish a paper in no less than a journal like Nature. And it's not just the end of it. Another example, while returning from London, and those days it was only the ship that you had. So he publishes another paper by looking at the color of the sea. Let me tell you here that one of the, in Raman's own word, Lord Rayleigh was an inspiration for C.V. Raman. And Rayleigh's contributions are widespread, but some of his prominent contributions are in the field of scattering, optics, and that's why we have even a Rayleigh scattering named after him. So Raman was closely following the works of Rayleigh, and the color of the sea was the hot topic during that time. And this also gets published in Nature, by the way, the color of the sea. And you see here the address, what Raman gives, SS Narkunda, Bombay Harbor. He makes the observation, does the analysis during the voyage, and writes the paper when he's in the ship. The moment he lands in Bombay, he posts the paper. So you can look at the systematic, if I may say so, or I'm not getting the right word, but a disruptively systematic way with which Raman worked. There was nothing like a set pattern. So whenever he got some very interesting results, he changed his style as and when it went. So here it is, one visit to a Whispering Gallery and one trip back fetches 2 Nature papers. So in 1924, by then Raman's work was well recognized throughout the world. And as a matter of recognition, he gets the membership, or he becomes a fellow of the Royal Society at London in 1924. And immediately when there's a celebrating this honor, when a party was thrown by Sir Asutosh Mukherjee, he just nonchalantly asked, "What next, Raman?" To which very confidently Raman replies without any hesitation, "Why, sir? The Nobel Prize, of course." So today it might sound very brash, it might sound very overconfident, very much pompous, but then that was Raman. He clearly knew this trajectory, his intellectual trajectory, and he also knew how relevant it was for that particular point of time. So for all of us who are in the field of research, this is one quality that we'll have to harbor. Intellectual exercise is one, but then how timely, relevant it is to the society, gauging that, judging that is also equally important. So this is where from 1921, Raman starts his works in the optics. So here he has sets up a small experiment for studying scattering of light by different liquids. By then, actually, Compton had published papers where he had reported scattering of X-rays in solids, right from early part of 1910s. And needless to say, in 1924 or 25, he got the Nobel Prize as well, Compton, for his Compton scattering. And that actually gave a fillip to Raman to accelerate his field of research in the optical scattering as well. And this kind of a contrivance where you see sun was a light source and there was a thin window aperture through which light was constantly made to pass in the same angle. And none other than Ashutosh Day had devised this contrivance with the guidance of C.V. Raman. So sun keeps moving, but then accordingly, this also rotates mechanically, of course, so that the light keeps traveling inside the lab in the same direction. And they had studied different liquid. What would happen in the black body enclosure if the exchange of energy took place by, and these are the different kind of questions they were asking. And they had seen something by that time, by 1923, that what they termed as a weak fluorescence. And just for the benefit of students, Compton scattering is a nonlinear scattering. What I mean by nonlinear scattering is whenever two bodies collide, you have exchange of energy. So if the energy before and after the collision of the colliding bodies are the same, this is a perfectly elastic collision where there is no exchange of energy happening. Whereas if there is exchange of energy, by which the energy of the colliding bodies before and after the collision are markedly different, that is termed as a nonlinear collision. What Compton had observed is that X-ray gets nonlinearly scattered by phonons and crystals. Now, Raman's objective or prerogative was to observe something similar in the optical domain as well, because all said and done, X-ray is just one end of the electromagnetic spectrum. So if something is true for one end of the electromagnetic spectrum, it ought to be true at other regions of the spectrum. And he had chosen visible region because of the readily available visible light source. And indeed, they had observed the nonlinear scattering and they had termed it as a weak fluorescence. So, so then in 1927, they make a very interesting observation that Compton scattering cannot be observed at optical wavelengths. And in 1928, Venkateswaran observed that the glycerine scatters light in green range. Scattering, by the way, I should tell you that whenever light interacts with any matter, there are possibly three different results. One, it can get absorbed by the medium on which the light is falling. Two, the light can get reflected. And three, the light can get scattered. The difference between scattered and reflected is the angle. Reflection has got a very specific angle, whereas scattering, depending upon the morphology of the system, the scattering is kind of, it's random, okay? And the nonlinear means that the wavelength of the light will get shifted. So in this year 1928 is very crucial, and very senior student K.S. Krishnan is the given in charge to take up the experimental work. And K.S. Krishnan has got very beautiful stories to narrate in his biography, because later on, after K.S. Krishnan went on to become the first director of the Physical Research Laboratory in Delhi. And he had very interesting stories to narrate with his association with C.V. Raman. So 7th February observes with a 7-inch lens that all his liquids exhibit the famous weak fluorescence. So irrespective of the liquid, they see that the observation of this weak fluorescence is universal. So they they were knowing what is going on, and then on 16 February, immediately Raman writes a note to the Nature with the title, "The modified radiation could arise from the fluctuations of the molecules from the normal state." And lo and behold, on 27 February, Raman decides to was on track through a direct vision spectroscope. But by the time Ashubabu sets it up, the sun has set. So there it has to wait. The different lens and the spectroscope here are slightly technical, but then there are different ways to amplify the incoming light which falls on the system. On the fateful day, 28 February, spectroscope shows that the track contains not only incident color, but at least another separated by a dark space. And 29 February, discovery is announced to the Associated Press. And 8th March, he sends a note again to Nature by Raman and Krishnan, but it is rejected by a referee. And interestingly, even though it is rejected by a referee, editor goes ahead to publish it. So this is how the paper is titled. This one is different. Yeah. So this is the endorsement by R.W. Wood, again a Nobel laureate, who said that the most convincing proofs of the quantum theory of light. Just to be slightly technical, I mean, by that time, this is 1928. So the Solvay conference happens in 1920. And by when the quantum theory gets slightly firmly established, of course, 27 is Dirac's comes into and introduces the relativity part. But that's to do with the spin of the electron, which could not be explained without invoking the relativity. But for these kind of experiments, you do not need to invoke the spin of the electron. So this is a nutshell to say that during those period of time, the quantum theory was just being developed, and people were curious to see in how many experiments this can be verified. And lo and behold, this experiment of Raman was also one such convincing proof. So these are some of the pictures for you to just have a look. And by the way, still this wooden box, but this is a spectrograph. This is well preserved by the Indian Association for the Cultivation of Science. And very often the replica is kept at the reception, and one can have a look. And this was the first the shift that they had observed. Due to want of time, I will go through. I will skip some of the things. So by the way, I should tell you that in 1928 he had announced it. He was so confident that he will get the Nobel Prize in 1929, but then he didn't get. And he was very confident that he will get the prize in 1930. So much so that you know that the Nobel announcements are made in October, but Raman had booked his ticket for 1930 in February itself.
I'm sorry, everyone. I think we've lost Ram for a little bit. I'm sure he'll join in a little bit. Just bear with us for a couple of seconds until then. Yeah, sorry, we have lost Ram. As I said, he is telling me that he'll be back in a couple of minutes. Until then, if you have any questions that you might want to ask, feel free to put them into the chat window on YouTube, and we will pass it on to Ram at the end of this session itself. But until then, please hold tight, and let's hope he's able to get back soon. As you all know, this is the perils of working online. Always tends to happen, but I'm sure he'll be back in a second.
I'm
Hi, Ram.
sorry,
Yeah,
there was a
welcome
net
back.
interruption in my side.
Yes, yeah. Now we can hear you. Can you please share your screen and then go ahead?
Yeah, just a second. Can you tell me where did I lose? Where did I miss? Was it this slide?
Yes, exactly.
Okay. So yeah, so there were controversies because there were Russian group which had also predicted, way back theoretically predicted in 1923. And to this day in Russia, in the scientific literature coming out in this topic from Russia, they don't refer to it as Raman effect. They either call it as a Smekal effect. And later, around 1928, the Landsberg and Mandelstam had also experimentally observed, but they were late in communicating their work by few weeks. So this is again a very important task, a lesson to all of us that we need to be very quick as well. So this is the controversy. I will not get into the point of time. There are different, I mean, just to say that pictorially explain what is Raman effect. If you look at this is incoming photon, this is a molecule keeps vibrating, and when the photon hits the molecule, it can either take the energy from the molecule or give the energy to the molecule or get reflected without any change in the energy. When it happens without any change in the energy, that is a Rayleigh scattering. And when it either gives energy or takes energy, that is a Stokes or the anti-Stokes shift, or which is what is referred to as a Raman scattering. Unfortunately, only 1 in a million photon gets Raman scattered because it's a very weak phenomenon. That's why, if you look at it, even though Nobel Prize was given in 1930, it had to wait. The avalanche in Raman papers of Raman effect had to wait until the discovery of, or until the invention of lasers, which happened in 1960. So now, if you look at the, I mean, this is also slightly old. You have large number of papers, but there's a hiatus from 1930 until 1960 because you need a brighter source because only 1 in a million photon gets non-linearly scattered. There are different applications and avatars, and that's what I said. Even Raman would not have anticipated this during his lifetime because once the laser had come, it had revolutionized the field. We can know the molecular structure, material characterization. We can look at low energy vibrations. We can directly image the cells and tissues. We can look at different ways to enhance the Raman effect. This is just one surface enhanced Raman scattering where you can make use of nanoparticles on which the molecules can get adsorbed. And once they're adsorbed, you can see that the Raman cross-section gets highly enhanced. Similarly, you can look at the cells and tissues through confocal Raman imaging. So you can look at this spectra is collected from each of this, and what you get is ultimately a data cube. And let me show you quickly one example. Okay, so this one you can look at cells and tissues as well, and in a very label-free manner. And of course, with lasers, you can have nonlinear optics as well, and because of which you have different variations of Raman, which are stimulated Raman scattering, coherent anti-Stokes Raman scattering, and both of them enhance the Raman scattered photon. Remember, as I said, Raman scattering is a very weak phenomenon. Only 1 in a million photon gets scattered. So there must be different ways by which enhancement can happen. One such way was surface enhanced Raman scattering. Other ways, by tapping into the nonlinear optics, there are stimulated Raman scattering, and these are like 4-wave mixing principles. For those of you who want to know more, they can get into the details of how 4-wave mixing is appearing in different versions for stimulated Raman scattering and coherent anti-Stokes Raman. I'll not get into the details. As I said, today Raman is applied in multiple fields. This is one such example of forensic science. Imagination can be wide. Yeah, just not a good researcher. Raman was not just a good researcher. He was a devoted teacher as well. So testimony from all his students are well documented, and he took teaching very seriously. So this is also another lesson because many of us flaunt our research abilities to compromise the teaching. as though some teaching is inferior, and some of us will flaunt our teaching and not shy away from the research. But of course, striking a good balance, it's like the Feynman. I mean, I would say Feynman is the Raman of US. Because Feynman is also counted one among those rare species who was both a very good researcher as well as a teacher. So Raman was a forerunner to him. So I will not get into this. He was also deeply rooted in our tradition and culture, yet having a scientific bent of mind, because here he boasts for saying that whenever he was called in America to speak about India, he says, do you think I spoke of Madras or of Calcutta? Because at that time they were the capitals. Because British colony, the most advanced cities were Madras and Calcutta. So he says, no, I didn't speak about them. Rather, I spoke of Kashi, of Benares, of the historic city on the ridge overlooking the Ganges, which stands as the very heart of India, as a living center of our ancient culture and learning. So this, you see, the kind of, he was not stereotyped, and he was not also like a monolithic approach. He had a very diverse interest, and he took interest in the tradition as well, albeit a scientific touch in it. He was at ease with politicians, and he did not spare to ridicule Jawaharlal Nehru at the drop of his hat. I mean, it goes on to say, and here you can see how enthusiastically Raman is demonstrating something and Nehru's onlooking it. And there are some guests from Britain as well. And on one such visits to Raman's laboratory, Nehru was tricked in front of an audience into identifying copper as gold, because when UV rays shine on copper, they shine with a golden luster. And to which Raman immediately prompted and said, Mr. Prime Minister, everything that glitters is not gold. For some reason, Raman was not very happy about the political setup just after the independence. And he did not mince his words to criticize the government of that time. And he was also not a very, indomitable ego that he had, the confidence bordering ego, whatever you may call it, made him run into problem with several people. He coined a term called Nehru Bhatnagar effect. Mind you, Bhatnagar here is SS Bhatnagar, after whom the Bhatnagar Award is given every year. And he coined this phrase Nehru Bhatnagar effect. And this is about the CSIR. And he says the CSIR is just like a Taj Mahal built to bury science. Okay. So he had that kind of an approach towards, and this again, my sincere apology to my friends and colleagues in RRI, because when Raman had raised for his money, asked for money to Nehru for the scientific upkeep of Raman Research Institute, Nehru asked, Raman, why do you worry about the future of your institute? Raman shot back and said, I certainly don't want this institute to become another government laboratory. Needless to say, today it has become a government laboratory. But of course, it is doing well. That's a different issue. But at that time, what Raman had in mind was comparing it with CSIR. These are different pictures of different scientists. So Radhakrishnan, this Birbal Sahni, Sommerfield, Neil Bohr, so on and so forth. And as I said, he had his own idiosyncrasies. He didn't go well with all and sundry. Although he was a director of a IASC, he was asked to step down, and he graciously tendered his resignation. And that's how he goes on to start his own institute, Raman Research Institute, with the help of the Nobel Endowment, as well as a copious endowment by the Wadayar King of Mysore. I would like to play a small audio where we can hear to C.V. Raman directly.
It's a certain plan. Do you think that you need expensive equipment in order to do good? Well, you sir, I wish I had equipment, but I don't have it, so that I've got to get on without it. So the difficulty is there's no question at all. We are in India, we are handicapped in many ways. No money, no equipment, and all the world throwing its goods at us. We have no time to do anything except try to absorb what they tell us. We don't have to think. So that's all very well. I don't think about it. We have to think the world when we find it. Work and think and study and do something about it. Get ideas, test them out. You have to be very honest with yourself and don't be satisfied with half-hearted explanation. Of course, it doesn't matter. Take photographs, study, do what you can with what equipment you possess. I'm not good very excited.
I mean, those of you who couldn't follow the accent clearly, the question was, what kind of handicaps do you have? And that's how C.V. Raman went on saying that we have handicaps in several ways. And he says, whatever equipment you have, you make use of it and you just don't complain. And I remember in one of his biographies, one of his students complained saying that their competitor in Europe has got 100 watt of light source, to which Raman immediately said, use your 100 watt brain instead of a 100 watt light source. So he was of that type. This is again his political comment, which is again a very harsh criticism on the government, where we see that legislative measures having expropriatory character and passage of taxation and other bills calculated to kill private enterprise in the field of industrial development. Democracy without freedom for the individual is a shame and delusion. So remember, this was against the Nehru government of that time. So how far have we come? Because today this is something that we often hear about democracy without freedom and freedom of expression is being curtailed, so on and so forth. So this looks like it's in our psyche to keep saying this. And we have even Raman who had talked about it way back. Very interesting thing about G.N. Ramachandran, who was a potential Nobel laureate, but he's famous, he's become famous by not getting the Nobel rather than getting the Nobel. But then Ramachandran had initially enrolled in the electrical engineering department, but Raman came across his intelligence and he grabbed Ramachandran under his group. And he wrote the letter to the head of the Department of Electrical Engineering saying that G.N. Ramachandran is too brainy for your department. That's why he has to work for me. So this is Raman Research Institute. Many people talk about the Kamala Sohoni, who was rejected a PhD scholar to pursue PhD during Raman's directorial tenure. But then, though people don't highlight that Anna Mani is also at the same time, by the way, who had graduated, who had done PhD with C.V. Raman. But it's a different story that she was not awarded the PhD thesis because the Kerala University at the time had a different rule. So to this day, Anna Mani's thesis is remaining unawarded. That's a different story, actually. Raman had his own idiosyncrasies, as I said, and he was making mistakes, several mistakes which were expensive. And this one I saw it in Twitter today, so I felt like sharing. So I leave it to the audience to spot the typographical error here. There's a very famous wave equation where it equates a second differential in space with second differential in time, which gives rise to the velocity of light. But there is indeed a typographical error, and a typographical error of a big magnitude for a Nobel laureate to make. But I will not get into that. So he leaves his mortal coil on 21st of November, 1970. And I quote him that science, in other words, is a fusion of man's aesthetic and intellectual functions devoted to the representation of nature. It is therefore the highest form of creative art. For him, science was nothing but art, or whatever you call his religion. That was the way he worked, right, throughout his life. And the tree marks the place where his ashes were buried. So the Indian government had commemorated by a stamp. And this is my last slide. So this is taken from the convocation address given at BHU in 1926, where he says he had a visit to Cambridge, and after going around the Cambridge University, he had a chat with Ernest Rutherford of the famous gold foil experiment. So he says to Rutherford, "It seems to me Cambridge is a place for play and not for study." Because he saw that in Cambridge, students were not just studying, they were doing everything. To which Ernst turned around and said, "We do not try to grow bookworms here. We train men who can govern an empire." So this, Raman goes on in his convocation address and says that there are bookworms of two types. One, bookworms generally only consume the book, but they kind of destroy it. We do not need any bookworms. What we need is people who can think way beyond just their survival, rather to even govern an empire. So just contrast the outlook what Rutherford and Cambridge had compared to what even perhaps we are having today. With that, I thank INYAS once again, and thank you all for your patience. And I'll be happy if there are any questions. I'm sorry I took a little longer time, but then.
Thank you, Ram. That was absolutely amazing. It was a pretty good overview, not just about the life of C.V. Raman, but also about the applications and how his personality developed through the years in terms of communicating with people around him. Thank you so much for doing this. As the very first lecture of our SIPP series, this was probably the best beginning that we could have hoped for. With that, I have a couple of questions which I'll ask you. We have a question from Priya Shekhar, who's asking, what are the most common everyday applications of Raman spectroscopy that you can see every single day?
I mean, one slide I showed, you have applications from forensic analysis. See, one thing, let me tell you, fluorescence is a label phenomenon. That is, even the green fluorescence protein also had got the Nobel Prize. You want to look at something, you tag it with a label and then shine light on it, and then you get to know about it. Raman has got a very beautiful feature that it exploits intrinsic molecular vibration and doesn't need any external label or an external agent. So that makes it liable to be applied, and you can think of anything, right? From people have applied it even during for the identification of coronavirus. Just to talk you in a very recent thing, for forensic analysis, for identifying protein folding, because many times it's very tricky to get in the label, and in situ protein folding looking at becomes very difficult. That is possible by Raman. So like that, I mean, I'm not able to crystallize a particular application, but there are n number of applications that you can think of using Raman today.
Actually, that relates pretty well to the latest question that we have, but I'll ask it now because it's a continuation from what you just mentioned, is what are your thoughts about the future biomedical Raman?
Of course. See, few years back when I was doing a postdoc, at that time, the state of the art was using a Raman microscope inside a surgical room in a hospital in UK. Okay, so that was few years back. Of course, it is still in a testing ground still. In India, we do not still have, there are only few groups which are on it. So the idea is, what happens is biopsy, whenever a surgeon wants to remove a part of your body, first a biopsy is done to confirm whether it is benign or a malignant tumor. Once it is done, then the histopathologist has to confirm it. Then the surgeon has to decide how much of area this has to be removed. I'm talking very specifically in case of oncology here. But with the Raman, now an oncologist, an oncosurgeon does not have to depend upon a histopathologist. Okay. And right now, of course, in India, that is not the norm. But in few places and hospitals in UK and Germany, this has already been this is already in place. So my look at it from purely biomedical application is that we might altogether get rid of histopathologists. I mean, apologies to them who are pursuing histopathology. But then with Raman, you can get rid of that completely. And with that, all the subjective bias, because very good oncological hospitals will not rely just on one histopathologist report. They'll have to do 2 or 3, then get a consensus, because histopathology is not a very absolute science there. It varies. So that's how I look at it, the future of biomedical.
Thank you. That question, by the way, was by Surya Pratap Singh. Another question we have is from Sakit Asthana, who's asked, how can we inculcate the same kind of approach towards work and science in ourselves as Professor C.V. Raman?
I wish I could answer that, but since I have not inculcated myself in my life, I dare not respond that. I can only talk about him. So I'm sorry, I do not know how to answer that.
I guess the best thing to do is get inspired by the work that he has done and try and do the best you can yourself also through hard work and, of course, making sure that you use your aptitude the best you can. Right?
There are no protocols for becoming successful. It's just that there is no recipe or there is no standard recipe. As I said, I mean, chance prepares a prepared mind. So. That is
That's
something.
true. Thank you. And the last question that I have over here is looking towards the future in terms of spectroscopy. So what is the latest in the world in terms of spectroscopy, and what are the unanswered questions that maybe the future generation should aim to answer in this world?
See, I think it was in 2015 or 16, Otto Heal of Germany had got the Nobel Prize for inventing something in the field. It is called kind of an optical filter, which actually goes beyond the diffraction limit. See, when you use light, what happens is there is something called Abbe's diffraction limit. That the spatial resolution which you can get is something like to the order of lambda by 2 if lambda is the wavelength of the incoming light. Okay. And those of you who are in the era still remember CD and DVD, you can understand, or in fact, for that matter, why even the blue LED got the Nobel Prize. It has got repercussions because data storage, as the wavelength reduces, lambda by 2 also reduces, and you can pack in more information. So what I'm trying to say is spatial resolution depends upon the diffraction limit. But this Nobel Prize of 2015 or 16 by Otto Heal broke the diffraction limit. So the way I look at it is now applying, there are people who are working on it already in Germany to combine that special optical filter with Raman microscopy. It's called a near field Raman microscopy, and that is something going to be of much more importance and application. That's how I look at it.
That's great. Thank you so much. The last question was by V. Ramaswamy, just to let the audience know. And with that, I think we've come to the end of our session. First of all, I'm so glad that the lecture for C.V. Raman was given by V. Ramanathan. So there's some continuity over there. So thank you so much for doing this. The talk was very nice, and I'm glad that we started off on this note. Just to let everybody know, the plan is to have these lectures once a month online. And besides that, please keep a watch on the INYAS social media platforms because we will be publicizing some of the new latest research done by Indian scientists on these platforms every single month. And with that, I will say thank you to everyone coming. I'm sorry, I think there is one more question, if you don't mind answering it. This is by Kritika Zambre. And she's asking if there are any resources to read up more on Professor C.V. Raman and his works that you can share with them.
About his biography, I shared it, the two books by Professor G. Venkatraman. About the applications, about the scientific part of it, any spectroscopy book, I mean, there is not one that I can put my fingers on, but any modern spectroscopy book will have about Raman, starting from the standard textbook of J.M. Hollis, which also discusses rotational Raman spectroscopy. Banwell gives you a very rudimentary introduction to Raman spectroscopy. In physical chemistry side, McQuarrie and Simon gives you, but these are from the curricular aspect. But about the popular part of it, yes, the biography by G. Venkatraman should be good enough.
Great. Thank you for doing this, and thank you for answering all the questions, Ramanathan. With that, we'll say goodbye to everyone and end the stream. But as I said, please keep a watch on the India social media platforms to know when the next talk will be, and also to know what latest research is going on in India. Thank you so much.
Thank you very much. And I once again put my words of thanks for INYAS, to you for hosting it so nicely. And just a word about INYAS, it's a platform for young scientists. So those of you who are wanting to do something different, I request you to apply for it. Although this year's application dates are already over. So please look out for it in the website for next year. Thank you very much.
Thank you. Goodbye.